a ship is heading east at 15 miles per hour. And so you're going to come here and you're going to have that ship moving to the east. So let's try that. So here's our ship and it's headed east. And so the vector, the direction is east, and we're going to put down the magnitude, which is 15 miles per hour. And I'm getting used to this pen still. All right. And then it said a tide it starts north and it moves 10 degrees east. So when we're doing the tide, we're going to start from the north and we're going to go 10 degrees. And then the tide, here's the direction, and the magnitude of the tide is 5 miles per hour. So now what we want to do is we want to figure out where the ship really is. What's the course of the ship after the tide moves the ship off course? And how fast is the ship going when we include the tide? So what we're going to do is we're going to draw a parallelogram. And so here's our parallelogram. And the resultant force is going to be this diagonal in the parallelogram. So here's the resultant force. And I know the picture's not the best. All right, so we're going to figure out the length of that resultant force, and that will be how fast the ship is going. And then we're also going to find the angle, which means we're looking for theta right there. All right, so how are we going to do that? The first thing we're going to do is we are going to look at this as a parallelogram. And we know that this angle right here is 10 degrees. And so we know that this angle is going to be 80. So this is 80 degrees, which means this corner over here. Okay, so what we're going to do is find the resultant. So how we find the resultant is we're going to use our law of cosines, which is side, angle, side. So here we go with this. We've got R, which is the resultant, is going to be equal to the square root of, and then notice one of the sides is 5, so we've got 5 squared plus 15 squared, subtract 2 times 5 times 15 cosine of 100. All right, you throw that into your calculator and you're going to end up getting 16.615. So that is the resultant, 16.615. So the tide is making the ship go faster than its 15 miles per hour. All right, the next thing we need to do is figure out where the ship actually is. So to figure out where the ship is, we're looking for theta. In order to find theta, so here's theta right here. In order to find that angle, we're going to use the law of sines. And do you notice that we have the opposite side, which is 5? So we can do the sine of theta over its opposite side, which is 5, is equal to the sine of 100 over that resultant side that I just found. And in your calculator, you're going to want to have stored this number, and you're going to want to use the full number. So instead of the decimal. All right, so you're going to go ahead, you're going to use the law of sines, you'll cross multiply, which gives you 16.615 sine of theta is equal to 5 sine of 100. Divide by 16.61 and then take the inverse sign. So theta is going to equal the inverse sine. Ooh, that's a little -1. Inverse sine of 5 sine 100 over 16.615. You're going to make sure your calculator is in degrees, right? So make sure you're in degrees, and then you're going to throw that into your calculator, and theta is going to equal 17.234 degrees. And so the ship, instead of going directly east, is actually headed 17.234 degrees towards the north. So east traveling north. So you can take this angle and clarify, say east traveling north.